Hey everyone, we're going to look at number 10 in section 3.7. We're just going to calculate the derivative, of course, using the chain rule. All right, so the chain rule, remember, is when we're taking the derivative, right? This is the differential operator, take the derivative with respect to x, and we need the function, and we're saying any function that is a composition. In other words, I have f being an outer function of, say, g of x. So g is the inner function. This is not f times g. This is not a product rule. You have to differentiate between the product rule, which would look like that. All right, that's the product rule. So that's different than the chain rule here. So what is the chain rule? When we take the derivative of a composition, it is the derivative of the outer function evaluated at that inner function times the derivative of the inner function. Okay. So that's what we're going to use here. We're going to take the derivative with respect to x of this function. Now notice it's all of this to the 1/2 power, which could have also been written as all this square root, right? So the 1/2 power means the square root. So we're really taking the derivative of this function, but it's good to write it in this form, obviously, because the first thing we're going to notice the composition is the inner function is cosine of 4x plus sine of x to the 9th power, right? And the outer function is u to the 1/2 power, or square root of u, right? So u to the 1/2 power. So we take the derivative of the outer function. What's the derivative of the outer function? That's just power rule. U to the 1/2 is bring the 1/2 down, u to the negative 1/2 power, where u is this inner function, times the derivative of that inner function u, right? Times the derivative of that inner function. So I just wrote that inner function with a prime mark. So what's the derivative in here? Well, notice I have the sum of two functions. So I'll take the derivative of this one and add it to the derivative of this one. And when I take the derivative of this one, notice I have a chain rule again. So I have chain rule sort of inside of a chain rule. Here we have outer function cosine, inner function 4x. What's the derivative of the outer function cosine? Negative sine, evaluated at 4x, times what? Again, remember the derivative of the inner function. The inner function is 4x. What's the derivative of 4x? It's 4. For this one, derivative of sine of x to the 9th, the outer function is sine. Derivative of sine is cosine. So it's cosine of x to the 9th times the derivative of that inner function x to the 9th. And the derivative of x to the 9th by the power rule is 9x to the 8th power. Okay, so we've got 1/2 times this times all of this stuff here. And so just cleaning this up a little bit, they said to use symbolic notation and fractions where needed. So I'm going to rewrite this negative exponent, right, as 1/2 times 1 over all this stuff to the positive 1/2, right? So that's just rewriting the negative as a positive exponent. Remember, the negative exponent means reciprocal, and times all this stuff. And I just clean it up a little bit, bring the 4 out in front of that, bring the 9x to the 8th out in front as the coefficient. And so cleaning this up, I've got 1 up top, 1 times all this stuff. So I'll put that stuff up there. 2 times this stuff. And I'll just note that this stuff, again, to the 1/2 power just means, as we said, the square root of all that stuff. So I'm going to write it that way. That would be the way I would write it. And I think Achieve will take that. Notice you could have rewritten the numerator, right, adding these two. I can subtract, change the way I'm adding it. 9x to the 8th cosine of x to the 9th plus a negative 4 sine of 4x is just 9x to the 8th cosine of x to the 9th minus 4 sine of 4x. So this would be acceptable as well. So it gets a little tricky when, what Achieve wants. So if you have any trouble, as always, please let me know. But this is what we get. Looks a little messy, and some of these derivatives with the chain rule, when we're composing different functions together, gets to be a little more complicated.